Hi, welcome to DappBlocks. In this video, we will learn how to deploy Solidity smart contract on Ethereum blockchain using Python. If you are new on the channel, my name is Himmat. Here we learn all fundamental concepts and practical development of blockchain technologies. So, if this is something helpful to you, then press the like button and subscribe to this channel. Let's get started. Prerequisite. First, Python. Install Python latest version. You can download it from python.org. Second, package installer pip. So pip is the utility to manage package installation from the command line. Python 3 will install pip by default. If not, you need to install it. You can check pip installed or not by using pip -version command. So first we will check the Python version. For that, Python -version. So this is Python 3.10. In your case, you will have the latest version. Then we need to install the web3. So pip install web3. So this will install our web3.py. I already installed this, so that's the reason it's saying requirement already satisfied. Then we need to install the solidity compiler. This is also I already installed. So for that, command is pip install py-solcx. So this will install your solidity compiler. Now let's go to the Remix IDE. There you will find the sample solidity codes or sample solidity contracts. Let's copy this storage contract. Here we have the store and the retry functions and one state variable. Just copy this as it is and go to the editor. We have the Visual Studio. So here create one folder, contracts, then create a file in that is storage.sol and paste the code over here. So just save this file, create another file to deploy this smart contract. So this is deploy.py. So here deployment. Okay. So first we need to read the solidity file. So read .sol file. Then we need to compile that file and create a ABI and bytecode out of that. Then we need to deploy it. Okay, let's start. Let's code it. So since this is the standalone script, we'll write if hyphen name equal to main then here first the file path, that is solidity file path. So soil underscore file underscore path equal to, just get the path from there. So right click and copy relative path. Okay, just paste it here. So this is the our solidity file path. Then we need to compile this file, read and compile this file. So write a function to compile this file. So this is the compile sol file. Okay, so function is define compile source file, and then here we need to pass one parameter. So oops, the syntax should be like this. Okay, so here we need to pass the file parameter, that is file path. Let's call this function and then pass this as well file path from here. Okay, now here first we need to read that file, solidity file. So read .sol file. Okay, so with open and the file path in the read mode, file path comma read. as as a file, then here file equal to f dot read. So this will read our file contents into the file. Okay, so file, then we need to compile this file which has the file content from storage.sol. So compile using the solcx. So for that, first we need to import that library or import that package. So import solcx, or we can write something from solcx. Import, we'll use the specified methods. So first we'll use the compile source. This is the method to compile the solidity file, and here we're going to write compile source. So compile file equal to compile source, and we need to pass this file as a parameter. Okay, this will compile our file and return as the compiled file detail. So return compile file. Okay, so here we need to create a variable to receive that return. So soil compiled file equal to compile source file. So here we'll get the compile file details or compilation details. Okay, so let's try and print some values from the compiled file. So compiled ID or compiled file name, solid compiled file. Just checking this. Okay, so we are just printing the compiled file as it is. So just run command python deploy.py. There is an issue. Let's see what is an issue. So error documentation tag. Okay, so let's go to the solidity file, and we have this custom dev over here in the comment. So this is specific to the compiler, so we can remove this. Anyways, this is in comment section. So for documentation it might use. So see, we have run this file and we have this compilation details. So here you will find the bin as a bytecode of the smart contract, then bin runtime again same, and we should have the API of the smart contract or the solidity. So see, this is the API. So we need the bytecode and the API for the deployment. Okay, so you might face another compilation issue. So for that you need to write this function, that is install solidity, install solec, and you need to write this install solidity and your compilation version. So this is optional. If you face any compilation issue specific to the solidity compiler, you can write this. I'm just mentioning because you might face this issue. If you face any compilation issue. Now let's print that ABI and the bytecode values or the compilation details. So first we need to retrieve the latest value or latest item from the output. So here we need the ABI and bytecode. First we need to retrieve the latest value from the compile file. So we can write sol compiled details equal to compile file dot. So this compile file dot pop item. So this will retrieve the latest value or the last value from the list. Latest item. So in the compile details, we'll find the ABI and bytecode. In the 0th position, we'll have the compilation ID or compilation name. Then try to print the ABI. So ABI is in the first position and the inside ABI tag. So compile detail of first and in the ABI. So this will give us the ABI, and then we need the bytecode. So bytecode is compile detail as well. So compile detail first of the then bin or the bin runtime. So this will give us the bytecode. So save this file and try and run it. So python deploy.py. Okay, see, first is compilation ID or compilation name is the storage. So then we have the ABI and then we have the bytecode object. Okay, now we need to deploy this. So deploy smart contract. So we need to write another method. Deploy smart contract. Okay, here we'll pass this compile details to this method. So call this method from here, deploy smart contract, and pass this value as a parameter to the method, and here receive this compile details as a parameter. Okay, see, now we need the ABI and the bytecode from the compile detail. So like we have print, we need to get those. So ABI equal to compile details of first element of the and then bin or sorry ABI. So this will give us the ABI. Then for the bytecode, we need compile details of first, that is first element, and the bin. So this will give us the bytecode. Okay, so we have the ABI and bytecode now. Now we need to connect our this script to the blockchain. Then only we can able to deploy the smart contract. So connect to the blockchain. So we need to import the web3. So web3, if you see there, import web3 is there. So just move that. Okay, so from web3 import web3. Okay, then create a variable, let's say w3, then equal to web3 in bracket web3 dot http provider, and here we need to pass the parameter, that is rpc url. So as we have seen multiple times, for ganache we can get the localhost, for others or testnet or mainnet you can get the rpc http url from the inferior.io. So here in this example we are going to use ganache blockchain. We are using this localhost. Then we need to get an account. So from which account we are going to deploy this smart contract. So account. So here in the ganache we have multiple accounts. Let's consider the first account or the 0th position account. So we have method for this. So w3 dot eth dot underscore get accounts. So this is the method to fetch the accounts, and we need the 0th position account. So for that of 0. So this will return this particular account 0. Okay, so this is the account or the wallet address to deploy the smart contract. Then we need to create a contract equal to w3 dot eth dot contract, and then we need to pass bytecode and the API as a parameters to the contract. So bytecode equal to bytecode, that is the second variable. Yeah, this is the variable, and then API equal to API. Okay, this is the contract creation, or the where we have created the contract. Then we need to build this contract with the help of from account and the gas fee. So build contract equal to contract dot constructor. We need to call the constructor of the contract, and then build dot contract dot constructor, and then dot build transaction. So this will build our deployed transaction, and here we need to pass parameters as the from address, as the from account address. We are going to deploy the contract, and then the gas fee from is, you can pass this account, and then we need to pass the gas price equal to, we can write method, we have method to get the gas price. So w3 dot eth dot gas price, that's gas underscore price. So this will return the gas price. So this will build a transaction for the deployment. Okay, now we need to send this transaction to the blockchain. So send transaction equal to w3 dot eth dot send transaction. We need to pass this build transaction as a parameter, build contract as a parameter. Okay, so this will send our transaction to the blockchain. And once this transaction is submitted to the blockchain, we'll wait for the contract deployment, and we'll get the contract deployed address or deployed contract address. So transaction receipt will wait for the transaction. So we have the method for this. So transaction receipt equal to w3 dot, let's change this invitation, okay, w3 dot eth dot wait for transaction receipt, and here we need to pass the parameter, that is send transaction as a parameter. So this function will wait for transaction to be completed and provide us the transaction detail. Connect to the blockchain, okay. And then here is a smart contract deployment. Okay, and from transaction receipt we'll get the contract address. So contract address equal to transaction receipt of contract address. So you can print this transaction receipt and you will find all the transaction details. Here we're going to use or going to print only the contract address. So we are fetching the contract address and will return this contract address as a return from this function. So this is deploy contract address. We're going to print or return from here. So let's return this from here, the contract address, okay, and go to the main. Okay, here we'll receive that the deployed contract address, and here we're going to print that. Print deployed contract address. This is deploy contract address. Okay, so let's save this file. Let's check one more time. Is everything okay? We have the eBay bytecode and then the connection. Okay, is there. Okay, then the contract, then the bill transaction sent, and wait for transaction receipt. Bill contract is there. Okay, send is there and wait for transaction. This looks perfect. Let's go and run this file. So python deploy.py. So you can ignore that info. So this is the deployed contract address. You can verify this contract address ending with 1E1. Go to the ganache, go to the transaction. See, this is the contract deployment transaction or contract deployed transaction ending with 1E1. This is the time, you can cross check. So 2003. So just now this block has been created with this one transaction in it. So here transaction count is 1. Okay, so this way you can deploy your smart contract using the Python web3.py. So here you can cross check or interact with the deployed contract. So first we need to connect to the ganache. So copy the RPC, select the environment here, ganache provider, paste it here. Then just copy this deployed address, and there is one function at address. Just what is an issue? Compiled. Okay, I not compile this. Just we have copied this side, click on add address. Okay, so see here we have these two functions, one is store and one is retrieve. So you can verify those methods from here, or else you can write code in the .py to access this smart contract. So we have the store and the retrieve. So here also you can write your code to access those methods. We'll see that how we can access the or connect to the smart contract in upcoming videos. So we can write connect or the access from here as well, or from remix. We'll try to save some value. So see, this is another contract call, and this is the second block got added with our contract call transaction, and this is the two transaction count for the first account. So you can again cross check the account, so ending with 77CF. So this is how you can compile and deploy smart contract using Python. Thank you for watching this video. Please like and subscribe to the channel, and I will see you in the next video.